Hello everyone, I am Jagdish Patel, Assistant Professor Sandeep Foundation Nasik. The name of subject is Digital Circuit and this is Unit 1 Digital Logic Family, and today this one is lecture number 1 in which we are going to see Introduction to the Classification of Digital Logic Families. I am having 12 years of teaching experience, specialization in digital communication. Starting with the Introduction to Digital Logic Families, a group of compatible ICs with the same logic level and supply voltage for performing various logic functions have been fabricated using a specific circuit configuration which is referred to as a logic families. That is, the logic families is a circuit configuration used to produce a type of digital integrated circuit. The entire range of digital ICs is fabricated using either bipolar device or MOS device or combination of two. So this one is the structure of classification of digital logic families or digital ICs. They are classified into bipolar and unipolar. Further, the bipolar are classified into saturated and unsaturated. The saturated are nothing but RTL, that is transistor resistor transistor logic, DTL diode transistor logic, DCTL direct coupled transistor logic, integrated injection logic I2L, high threshold logic HTL, transistor logic TTL. And in unsaturated, they are further classified into Schottky TTL and emitter coupled logic ECL. Whereas unipolar are classified into three types: PMOS, that is P channel MOSFET, NMOS, that is N channel MOSFET, and CMOS, that is complementary MOSFET. Classification of digital logic families based on this table. In this, the first column explains the IC classifications. In second column, we are going to see equivalent individual basic gates, number of components in third column. So starting with the first one, SSI, that is small scale integration, it requires less than 12 gates and number of component up to 99. In medium scale integration, MSI, it requires 12 to 99, in between 12 to 99 gates, and the number of component varies between 100 to 999. The next one is large scale integration, LSI, which required the basic gates ranges from 100 to 999 and the number of component ranges from 1000 to 9999, that is 9999. Next one is very large scale integration, that is VLSI, which requires the basic gates above 1000 and the number of components above 10,000. TTL, transistor logic, is a standard logic families used for longest time. ECL, emitter coupled logic, suitable for system requiring high speed operations. Next is MOS, metal oxide semiconductor logic, suitable for system with high component density. Next is CMOS, complementary metal oxide semiconductor logic, suitable for system with low power consumption. VLSI circuits basically gradually becomes dominant logic families. Starting with first one, TTL logic families, first introduced by Texas Instruments in 1964. TTL has sharp digital technology in many ways. One of the most widely used families for small and medium scale devices, rarely used for VLSI. Standard TTL families, example 7400 is obsoleted. Newer TTL families still used. High energy consumption but relatively insensitive to electrostatic discharge, and distinct features. So this is nothing but DTL family evolution, 74 series. After that it comes with 74S series, 74LH series, 74AS series, 74ALS series, and 74F series. The 74 series, 74, 74S and 74LH do not use in new technology, but 74AS and 74ALS series are widely used nowadays. Next one is ECL, emitter coupled logic, based on BJT but removes problem of delay time by preventing the transistor from saturating. Very fast operation, propagation delay of 1 nanosecond or less is required. High power consumption, perhaps 60 milliwatt per gate. Logic level zeros, 1.7 volt and 1 requires 0.8 volt. Negative. Such a strange logic level requires extra efforts when interfering to TTL oblique CMOS logic families. Low noise immunity of about 0.2 to 0.25 volt. Used in some high-speed specialist applications, but now largely replaced by high-speed CMOS. So these are nothing but the specifications related to ECL. Now next one is CMOS, that is complementary metal oxide semiconductor. Considerably low energy consumption than TTL and ECL, which has made portable electronics possible. Most widely used family for large scale devices. Combines high speed with low power consumption. Usually operate from a single supply of 5 to 15 volt. Excellent noise immunity of about 30% of the supply voltage. Can be connected to a large number of gates, about 50. Things to watch out for: don't leave inputs floating in TTL. This will float to HI. In CMOS, you get undefined behavior, susceptible to electronic damage. So this one is a CMOS family evolution. 4000 series, after it comes with 74C series, 74HC oblique HCT series, then 74AC oblique ACT series, then 74AHC oblique AHCT series by CMOS logic, and 74LVC oblique ALVC oblique LV oblique AVC series. So these are nothing but the different series which are comes under the CMOS family evolution. Power reduce is one of the key to progressive growth of integration, and which is the advantages of CMOS family. Few common ICs that are used for fabrication of basic gates, that is 7400 quad 2 input logic NAND gate. Next is 7402, that is quad 2 input NOR gate. Next is 7432 quad 2 input logic OR gate. Next is 7408 quad 2 input AND gate. So if you observe, all the basic gates having 14 pins, and inside each gate it is fabricated, the IC is fabricated consists of 4 NAND gate, 4 NOR gate, 4 OR gate and 4 AND gate. So every IC is internally connected or internal structure of every IC consists of 4 gates. The connection fashion of the gates are shown internally here in the slide. The pin which are left, that is every basic IC is having 7 number pin which is connected to ground, which are used for grounding, and the 14 number pin is used for VCC connection. TTL and CMOS logic families, subfamilies, are nothing but transistor are TTL, logic families are nothing but for TTL, low power, high speed, short key, low power short key, advanced short key, advanced low power short key, and fast. And symbolically they are represented as low power for L, high speed for H, short key for S, low power short key for LS, advanced short key for AS, advanced low power short key for ALS, and fast for F. And before this also, two slides before, we have seen the different configuration of TTL and CMOS families. In that, this L, H, S, LS, AS, ALS, F, these type of words were used. So which defines the family in which that particular IC belongs to. Next is CMOS. CMOS is having two families, high speed and advanced. For high speed, it is denoted by symbolically HC and advanced AC. Various series of TTL logic families. So these are TTL series: standard TTL, high speed TTL, low speed TTL, Schottky TTL, low power Schottky TTL, advanced Schottky TTL, advanced low power Schottky TTL. And the prefix and the examples for that particular family ICs are starting with 74, after that 74H high speed, 74L for low speed, 74S for Schottky, 74LS for low power Schottky, 74AS for advanced Schottky, 74ALS for advanced low power Schottky. And the examples are 7486, 74H86, 74L86, 74S86, 74LS86, 74AS86, and 74ALS86. So these are nothing but the number of ICs and their families according to their families under which comes under TTL logic families. These are the various series of CMOS logic families. As we have seen the TTL logic family, similarly in the same fashion CMOS logic families are listed here. Original CMOS pin compatible with TTL, high speed and pin compatible with TTL, high speed and electrically compatible with TTL, very high speed and pin compatible with TTL, very high speed and electrically compatible with TTL, advanced high speed and pin compatible with TTL, advanced high speed and electrically compatible with TTL, fast and electrically compatible with TTL, fast and electrically compatible with TTL-V. And the prefix of the same are 40, 74C, 74HC, 74HCT, 74VHC, 74VHCT, 74AHC, 74AHCT, 74FCT, 74FCT-T. And the examples are 74990, 74H04, 74HC04, 74HCT04, 74VHC04, 74VHCT04, 74AHC04, 74AHCT04, 74FCT04, 74FCT040. So these are the examples, prefix and CMOS series for various different specifications. So in this way we have seen classification of digital families which are classified into TTL, next is ECL, next is CMOS, and in this way we have seen the specifications of all the families. In the next lecture we are going to see detail about each families and its specifications and its implementation. Thank you.